California catches on fire a lot. In fact, wildfires cause billions of dollars of damage to property and impact hundreds of thousands of people every year, and they're only getting worse. Two of the major approaches to mitigating wildfires are extinguishing the fires before they become too severe and eliminating possible sources of ignition. And you know what's really good at setting dry grass on fire? Hundreds of thousands of volts of electricity suspended above the ground on 80-year-old power lines. Now, enter the idea for our project, LineAlert, a low-cost package of sensors that could be easily attached to power lines in remote locations. LineAlert is powered by the magnetic fields of the power line it's attached to, and it communicates through its own mesh network instead of cell towers. It's able to remotely monitor power lines and identify any faults when they happen, and the network of devices together can quickly pinpoint where these faults occur. Our device contains an accelerometer, which can detect how much a power line is swinging in order to gauge the risk of conductors touching. It can also detect impacts to the power line from falling supports or possibly flammable objects coming into contact. Angle information from the accelerometer, in combination with the line temperature sensor, can detect the severity of line sag due to overheating. The LineAlert device also has 4 infrared sensors which are always watching for nearby fires and can report their relative direction and approximate size. At the center, there's a set of current transformers which feed information into a digital signal processing algorithm, allowing the device to monitor for current waveforms that could be indicative of arcing. It can also, of course, report the location of a major failure. The current transformers are also connected to a special power converter circuit which can harvest all the power the device needs to function directly from the power line. A backup battery is continuously charged while the power line is live and can take over in the event that the line is de-energized. Finally, we have a camera which can be used for remotely inspecting the insulators supporting the power line in order to monitor for wear or damage. With these sensors, a grid operator could see the location and nature of almost any kind of fault that could occur on a power line. To communicate this information, we have an antenna integrated into the Faraday cage around the device to protect it from the strong electric fields around a power line, while allowing communication through. The communication protocol uses other LineAlert devices on the power line to relay messages along until they are ultimately received by a device at a substation or anyone else within range. This allows live updates about power line hazards and fire information to be immediately received by the power company or emergency responders, helping to improve the maintenance of power lines and reduce the risk of severe wildfires.